Materials Engineering Review, Past Exam Part 3 by Engr Pogs. Don't forget to click the subscribe button to be updated on the latest upload. Number 26. Atterberg limits comprise the following except. Let's define first what is Atterberg limits. It is a basic measure of the critical water contents of fine-grained soils such as silt and clay as they transition from a solid to a liquid. Atterberg limits consist of shrinkage limit, which is the transition from solid state to semi-solid state, plastic limit, transition from semi-solid state to plastic state, and liquid limit from plastic state to liquid state. Therefore, the answer is letter D, consolidation test. Number 27. For determining the liquid limit, a special standard cup device is used. All dimensions of the device are fixed and the jarring is accomplished by turning the crank at the rate of blank revolutions per second. Based on AASHTO T89, determining the liquid limit of soils, on its procedure number 5, you need to lift and drop the cup by turning the crank at a rate of approximately 2 revolutions per second. Therefore, the answer is letter B, 2. Number 28. The moisture content when the groove is closed by blank blows of the cap is defined as the liquid limit. Again, based on AASHTO T89 determining the liquid limit of soils, the moisture content at the intersection of the flow curve and the 25 shock line is the liquid limit. Therefore, the answer is letter B, 25. Number 29. The required number of hours in soaking a soil specimen for C.B.R determination is based on ASTM D1883 or standard test method for California bearing ratio of laboratory compacted soils, you need to allow the specimen to soak for 96 plus negative 2 hours. Since ang nasa choices is 96 hours lang, therefore the answer is letter B, 96. Number 30. As an experienced material engineer, without the aid of laboratory equipment, it happens that your sample is hard. What practical method will you use in determining whether your hard sample is soil or rock? I think the best practical method on the choices is by submerging the sample into the water. Number 31. In road construction, the excavated material was 705,900 cubic meter, and the waste was 505,600 cubic meter. How many grading, compaction, plasticity tests are required? The given in this problem are excavated materials, 705,900 cubic meter, waste material, 505,600 cubic meter. Based on the minimum testing requirements, if excavated materials are incorporated into the work, for every 1,500 cubic meter or fraction thereof, you need 1 grading test, 1 plasticity test, and 1 laboratory compaction test. Let's calculate the volume of soil that will be incorporated into the work. That was equal to the amount of the excavated materials minus waste material, which is equal to 705,900 cubic meter minus 505,600 cubic meter, which is equal to 200,300 cubic meter. Ito lang yung volume ng material na gagamitin natin sa job site. Therefore, the number of tests is equal to 200,300 cubic meter over 1,500 cubic meter. And the number of tests needed is equal to 133.53, say 134. Therefore, the answer is letter A, 134. Number 32. What is the estimated diameter of the soil thread when rolled between the palm of the hand and the glass plate that begins to crumble in plastic limit determination? Based on ASTM D4318, standard test methods for liquid limit, plastic limit, and plasticity index of soils, the thread shall be further deformed on each stroke so that its diameter reaches 3.2 mm or 1/8 inches. And the answer is letter B, 1/8 inches. Number 33. The following are the simple visual and manual tests used for the identification of fine-grained soils in the field without the aid of laboratory equipment, except the answer is letter D, grading, kasi madami tayong equipment na ginagamit sa grading. Number 34. The following data were obtained from a sieve test on a certain soil. The question is, what is the percent finer at sieve number 200? Ilagay lang natin lahat ng given na weight sa problem that corresponds for each sieve sizes and calculate the cumulative mass retained above each sieve. For sieve number 4, the mass retained is equal to 60.50 grams. For sieve number 8, the mass retained is equal to 75.1 plus 60.50. For sieve number 20, the mass retained is equal to 85.5 plus 135.60, which is equal to 221.1. Sieve number 40, the mass retained is equal to 77.9 plus 221.1, which is equal to 299 grams. For sieve number 100, the mass retained is equal to 161.60 plus 299 equal to 460.6. For sieve number 200, mass retained is equal to 29 plus 460.60. And for the pan, the mass retained is equal to 67.60 plus 489.60, which is equal to 557.2. And the total mass of the soil sample is equal to 557.2 grams. To calculate the percent finer on each sieve sizes, we need to use the formula percent finer is equal to the summation of the mass minus weight on the column 3 or the weight of the cumulative mass retained on each corresponding sieve sizes over the summation of mass multiplied by 100%. For sieve number 4, that was equal to 557.2 minus 60.50 all over 557.2. And the percent finer on sieve number 4 is 89.14. Continue doing this on other sieve sizes. And looking at the sieve number 200, since ito yung nasa problem, the percent finer on sieve number 200 is 12.13. Therefore, the answer is letter C, 12. Number 35. You are the material engineer of a certain company doing an earth road construction. During the progress of construction, highly organic soil was encountered. What will you recommend to your firm? Based on DPWH Blue Book 2013 Section 104.2, materials containing detrimental quantities of organic materials such as grass, roots, and sewerage are considered as unsuitable materials. Therefore, we need to remove and replace highly organic soil with more stable materials. And the answer is letter B. Number 36. Good compaction means except A. Subsequent settlement is minimized. B. Stability is increased. C. Resistance to water absorption is decreased. And D. Change in moisture content is minimized. And the answer is letter C. Resistance to water absorption is decreased. Why? Kasi kapag maganda yung pagkakakompact sa ating soil, mas tumataas pa yung resistance ng soil sa water absorption. Number 37. The volume of common barrow materials in its natural state at source is 4.48 cubic meter. The volume of common barrow materials in track at job site is 4.81 cubic meter. The swell factor will be, the given in this problem are volume of soil in the natural state at the source, which is 4.48 cubic meter, the volume of the soil in the track at job site equal to 4.81 cubic meter. The formula for swell factor is equal to the volume of bank or the natural state over volume of loose or the disturbed state multiplied by 100. The volume of bank or the natural state of the soil is 4.48 cubic meter and the volume of the loose soil or the disturbed state of the soil is 4.81 cubic meter multiplied by 100. And the swell factor is equal to 93.14%. And the answer is letter C, 93%. Number 38. In applying load on the penetration piston in C.B.R determination, the rate of penetration is approximately, based on ASTM D1883, standard test method for California bearing ratio of laboratory compacted soils, apply the load on the penetration piston so that the rate of penetration is approximately 0.05 inches or 1.27 millimeter per minute. And the answer is letter C, 1.27 millimeter per minute. Number 39. The required area for the construction of control strips and determination of target density is, based on DPWH Blue Book 2013, Section 106.2.2, a control strip shall have an area of approximately 335 square meters. And the answer is letter B, 335 square meter. Number 40. Soil sieves will not give information on A. Size of grains, B. Size distribution, C. Soil classification, and D. Mass weight passing. And the answer is letter C. Soil classification. You can watch the continuation of this video on part 4.